This video is going to show how to set up a ToolPath template to be used with the copy and paste from Cabinet Parts Pro to Vectric product. This process could be done either in Aspire or VCarve Pro. In this case I am using Aspire, but the process is the same for VCarve Pro. I'm going to start off by clicking New to set up a new job. The material that I'm going to enter in, or the job size, is the size of my plywood, X96, Y48. I'm going to zero the Z to the table surface. In cabinet making, the Z axis zeroing to the table surface is going to give you the best option here. The reason for that is in cabinet making you want to not cut into the spoil board any more than you necessarily have to. The more depth you get into the spoil board, the less chance your vacuum system is going to hold that part. So very little cut depth into the spoil board. And by zeroing to the table surface allows for a little bit of material thickness variation. So if we get in this case, I have the thickness set to be 0.75, I actually might get the material in and it's 0.73. Well, that 0.73 really isn't going to affect the overall build of the cabinet. It might affect the overall size slightly, but it's really not going to affect any of my dados or anything that I have entered in here. So by setting it to the table surface is a way to allow for material variance in thickness. My X and Y position is going to be 0 to the lower left. I'm working in inches and selecting OK here. Now this video is also going to show how the process of setting the template up is for importing vectors from a DXF file that has set depth to it. A lot of DXF files are able to set the depth of the line or the vector that is drawn. It's able to give it a depth. Vectric, Aspire, or VCarve Pro really doesn't show that depth anywhere, but it does read it and understand that it has depth. And this only works for imported DXF files. So now I'll go into File Operations and import vectors from a file, selecting a sheet, and this sheet represents pretty much all the toolpaths that I'm going to be calculating for. It is a layered DXF drawing, so if we go to the layers, we now have layers listed here, and we could see what layer has objects drawn on them by the little icon here. You can see a little bit of icon looking different here than it is for the 0 layer and layer 1. So the only layers that have geometry on them there are 5 layers here. So to make things a little cleaner for me, I'm going to right click and delete the layers that do not have any geometry on them, so that I know the only toolpaths that I need to calculate for and apply to a layer are the ones that are showing in my layer list. So to do this, I don't need any drawing anymore, but I am going to leave the layer list open because I'm going to use this layer list to make sure that I get the naming just right. And I want my toolpaths to be matched up and named by the layer that they're associated with. It's just a nice way to organize your toolpaths when you're using ToolPath templating, to understand what that toolpath is for, you know, another month, 2 months, 3 months from now when you're using that same template. So with leaving this open, I'm going to go over to the toolpaths and check the little tack to lock it open, and I'm going to start at the top of my layer list and work down. So the backside dados are the dados that are for the back and on the sides, and we can see that by selecting that vector, coming down, and see that it is on the back side dado layer. So the first thing I'll do is select to rename the layer and just do a Control-C or a right-click copy. For this layer, we need to use a profile toolpath, possibly a pocket toolpath, depending on what diameter bit you're using and the width of the dado. In this case, I'm going to use a 1/4 inch dado, and this dado here is only, I believe it's 1/2 of an inch wide. So a pocketing toolpath isn't necessary. I could just use a profile toolpath. Selecting the profile toolpath, I'm not going to worry about the depth, just to show what we're doing here. I'm going to enter 0 so we can see how that's applied later. I'm going to select the cutter. In this case, it's already selected. Just select another one here. Make sure I'm selecting from the same file or the same cutter for every one, so I don't get a mix match of tool numbers or geometries or anything that might get in the way. I'm going to use the same 1/4 inch cutter throughout this toolpath template. Going to machine the vectors on the inside, and the real happenings for this in setting up a toolpath template is going to be using this selector. So clicking the selector here says that a way for us to automatically select vectors. So I want to select only closed vectors, all closed vectors. I want to associate this selection with my toolpaths, or all vectors that are on this layer. Or what that means is, since I have this checked, when I click recalculate, any newly drawn vectors on the layer that I'm associating it with will then also be calculated and included with that toolpath. The other option that I am going to set here is set the toolpath cut depth from the imported vectors. So setting that will then give us a depth. In this case right now it's saying that no objects or anything has been selected. The reason for that is I need to set, I only want to select vectors on the selected layers. And I am only going to select the backside dados. And as soon as I check that, notice that our side dados have automatically been selected. And we could see our selection Z value is a -375, so they're 3/8 of an inch deep. And we'll see why we need to pay attention to what this minus is about here. Since we've chosen to 0 to the table surface, we have to offset for our material thickness. And before I do that, I'll just show what happens by not doing anything here first. So the selection is all set up. I'm going to click close. And notice that our cut depth now says 1.125. We definitely don't want it cutting that deep. But why did it come up with 1.125, 1 1/8 inches? Well, we set up our material thickness to be 3/4 of an inch, which is 3/4 of an inch plus, or actually in this case, minus our 3/8 of an inch. So 3/4 plus 3/8 is equaling 1 1/8. So what we need to do is subtract our material thickness out of this depth selection. So to do that, we're going to go back into the selector, and we're going to use Vectric's variables, T, which is for thickness. So if I just enter in T and hit equals, that's going to equate that to be 0.75. But remember, we need to subtract T. So I could just enter in a minus and leave it just as it is here, 0.75. But this toolpath template may be used later for 5/8 material, or 1/2 inch, or whatever material thickness. So we want this setting to be able to float with whatever material we enter in our job setup. So instead of leaving this as a number, I'm going to enter in minus T. Select and close. Now we can see that our total cut depth is 3/8 of an inch. I'm going to give this a name. Remember when I went to rename the toolpath and copied that name, I did that so I could come down here and paste it. That way I ensure that the toolpath name that I'm giving it over here is matching up with the layer that I'm associating it with. So at this point, I'll click calculate and close this template, move on to the next in the list, which is my cut. The cut is the perimeter cut. Same process. profile toolpath. I have the same cutter selected. I'm not going to worry about the cutting depth. Setting to cut on the outside. Coming down to the selector. Going to select close vectors. I'm going to associate. Now remember what we have to do is the minus T to subtract out the material thickness since we're zeroing to the table surface. If we had the option set to 0 to the top of the material, we would not need to do anything here. The Z offset could be 0. Select vectors only on the cut layer. Selecting close and giving that a name, and I am going to name it exactly as it is named by the layer. Selecting calculate, then close. We'll now move on to the toolpath for the drawer holes, which is going to be a drilling toolpath. I'm not worrying about the depth, but I do want to select the same cutter that I'm using for the rest of the toolpath, so I don't get any geometry errors when I'm calculating, or geometry different, or tool numbers are different there. So now I'll go into the selector, closed vectors. In this case, I could even say only circles, but I do know only circles are on that layer, so I'm going to associate, offset by minus T, which is the thickness of material, choosing to select only the drawer holes, close, right click, rename, control copy, rename the toolpath, calculate, close, repeating the process for the shelf holes. For this one I could just do a duplicate, a rename here so I could get a control C or a copy, rename this toolpath here to do a paste, double click the shelf holes toolpath. The only thing I need to modify here now is within the selector to uncheck the drawer holes and check the shelf holes. We'll close, calculate, close. The last layer in the list is the hinge holes, which is again the same as the shelf hole, so I'll just duplicate the shelf hole layer, right click on the layer name to rename that, do a control C to copy, right click on the toolpath name, the copy toolpath name, and a control V, and again just double clicking or right click edit. The only thing I need to change here is the selector to uncheck the shelf holes, check the hinge holes, close, and calculate. We now have all our toolpaths calculated for this job. I'm going to select the cut, move it down in the list, so that will be the last thing that gets cut, applied. Just making sure that we have everything calculated correctly. Go to the 3D preview, click preview, and preview all toolpaths. All toolpaths calculated just fine. Then we will, next step is to check all toolpaths to make sure they're all visible. Go back to the 2D view to see how this looks too. So all toolpaths are now visible. What we now want to do is go in and save these toolpaths out as a template. So the next time we bring this DXF drawing in, or another DXF drawing that has the same layers set up with the same depths, or maybe varying depths, but with the same names, all we have to do is import or load that toolpath template and recalculate. So to do that, we want to save selected toolpaths as a template. This is one that gets me in trouble a little bit. I a lot of times click this option right here, and the only thing this button is going to do is save the selected toolpath. In this case, the only toolpath that I have selected is cut. We can see it's bold there, it's a different color. So that would be the only toolpath that gets saved out to a template. The option that I really want to have is this one here that says all visible toolpaths as a template. So in this case, every toolpath that I've calculated here is visible, meaning that it has a check next to the toolpath, and meaning visible is I am able to see it on my 2D view or on my 3D view. So I uncheck the toolpath, I see it is no longer visible, so it would not save out with this template. I do want it saved and all of these saved, so having them checked to all visible, selecting save. Now it needs to give it a name. I want to give it a recognizable name that you're going to know what it is the next time you need to use it. So I'm just going to name it Basic Cabinet and clicking Save. Now that is set up a process to where we don't have to go through the process of selecting all our vectors and calculating and go through all our toolpaths once again. That they're done. So to show what we have done here, I'm going to click New. I do not want to save my changes. Same 9648, 3/4 thick. And now I'm going to import vectors, sheet number 2. So no toolpaths that are associated with this yet. As we see, our toolpath list is empty. So since we already saved our template out using the Save Templates to a file, or toolpaths to a template, now all I just have to do is click Load Template. I'm going to select that same template that we had saved earlier, selecting Open. We now have our toolpath built, but no toolpaths have been calculated that we see yet. The reason for that is we have to click Recalculate All Toolpaths. Once we do that, we see that they all become visible and all toolpaths are calculated, viewed, and we could preview them. Now where that template works is within Cabinet Parts Pro, we're able to use the built-in gadget or the modified Apply Toolpath template to all sheets. So I'm going in, setting up a new job, same dimensions that we were using before. Now with that template selected, I'm going to go to Cabinet Parts Pro, enter in a couple cabinets. I'll enter in just a base cabinet, do 3 of those, and we'll just do a wall cabinet here as well. Do 1, add the cabinet, going to calculate nest. Now again, if we choose not to use the built-in toolpathing from Cabinet Parts Pro, we could copy this to Vectric. And I'm going to do so by first setting up and setting that I want to show the dialog, which is going to be the dialog that opens up to allow me to select a toolpath template. I'm going to use the same toolpath template that we had just created. So after that box is checked, I'm going to go to Tools, copy to Vectric, get a message ready to paste into Vectric. Going to Vectric, I could either Control-C, go to Edit, Paste, or right-click, Paste. Our Apply Template to all sheets is opened up. This gives us a chance to select a toolpath template. The toolpath template I chose to save is on my desktop under Cabinet Toolpaths, and here's our basic cabinet toolpath template. Select Open. If I want to automatically save these toolpaths out when I select OK, we could do that. They will all save to our folder that we have selected within this gadget. In this case, it is Users on my desktop, Cabinet Toolpaths. Once I select OK, the DXF drawings or the drawing from Cabinet Parts Pro nesting has been imported into Vectric on the 3 sheets. You could click on a sheet, double click on a sheet to view, and we see that they are toolpathed. under the ToolPath list, we have the name that we named our toolpath with a prefix of S1 through S3. The S1 to S3 is indicating the sheet that toolpath is calculated for. So S1 is sheet 1, and we have all the datas here, and all the cutting files and all the toolpaths that are associated with those layers, and those same layers that we had used when we set up our template. I hope this was a useful tutorial. Have any questions, please let me know.